Hi, I'm Hannah Laird with the Sensory Kitchen, and today we're going to show you how to set up the Warner-Boxer Shear Force test.
When testing for Warner-Boxer Shear Force, we actually use this to core the meat samples. The cores from this are what's used to put inside the machine and used to test how tough the meat is. We have here pork loins and pork tenderloins. They were cooked earlier this morning to a specific degree of doneness. They were put in the cooler so they'd all be the same temperature when we do the cores. This is important because it helps with consistency whenever running the cores, and it helps you to get a cleaner core at the end. So when actually taking cores of the samples, you want to make sure to get 6 cores from each product. This makes sure you get an accurate measurement from the steak itself and not something where you catch a fat pocket or a piece of connective tissue or something like that that'll throw off your results. So when coring, you're going to cut into the steak off, and that'll show you the muscle fibers. When coring, you want to make sure to take your cores parallel to the muscle fibers. So that way you actually get a test of the tenderness of the muscle fibers themselves and not just a random assortment of the meat. As you can see in this loin chop, these are the directions of the muscle fibers. So we're going to take the core and we're going to run them parallel to the muscle fibers in order to get our cores. It's important to use a little bit of force but not push too much, and just use a twisting motion. If you push harder than instead of just spinning, it's actually going to give you some ugly cores and they won't all be uniform. And there's our first core. As you can see, it's a decent core, and you can see along the sides that we did in fact get all the muscle fibers. And whenever you run it in the machine, the blade will actually cut through the middle of the core. I start in the middle just to make sure I get the whole meat, and I don't start on the side where there's fat or connective tissue, or if I start too far on the other side, I'm not going to get a long enough core. Here we have our full 6 cores. It was cutting it close, but we made it. If you do find a product that's too small, like our pork tenderloin we will have in a minute, you can run this test accurately with 4, but you prefer 6. When coring a smaller product like a pork tenderloin, you still have to cut the edge to see which way the muscle fibers are running, but you want to get as close as you can to the edge so you're not wasting any product. We can see just by cutting that up, its tenderloins are running straight up and down, and so that's how we're going to core them. Tenderloins are sometimes difficult to core because of how tender they are. If you use too much force, or if they're cooked to a lower degree of doneness, they have a tendency to just fall apart in your hand. So that's why, especially for tenderloins, it's extra important to be sure to let them sit and rest after cooking and come down to room temperature, or even leave them in the cooler like we did. Here's our first core. It turned out pretty good. We got all the muscle fibers and we actually held it together. In industry, they talk about an hourglass shaped core. That's something you don't want to do because it's thinner in the middle and it's not uniform and won't give you an accurate description of a core that is perfectly uniform. This tends to happen on something like tenderloins. If they're cooked to a lower degree in doneness, you can force too hard and it'll actually just twist and twist, and you'll get almost an hourglass shaped form to where in the middle it's thinner and the outer it widens out. Try to see if I can get an hourglass shaped form for y'all. These pork loins were cooked to a little bit higher degree of doneness, so it may not be as easy, but we're going to try. This one isn't quite hourglass, but it is kind of corkscrew looking. It's not real uniform in shape as some of these others, and you can see how it's misshapen. So this is the United Testing System. This is the system we use here at Texas A&M. Whenever we're testing, we're looking at the Y max. The Y max shows you how many kilograms of force it takes to cut through the muscle fibers. So whenever you start, it's important to make sure to zero out the machine. When you zero out the machine, you want to get it ready for as you would actually test the core. So we're going to go ahead and jog it down. And you want to jog it down to enough to where really you can just fit the core in, and then not too much further than that. This is because you don't want the machine running further than it has to, because the further it goes, the more friction it has rubbing against the machine, and the more varied your results will be. So we had the machine set up ready, the distance we want it to be. We're going to go ahead and test it. You have to test it every 10 samples. So every 10 samples or every 60 cores. Hit T twice, and the machine's going to go ahead and start coming down as if there was a sample there to cut through. When finished, you can see our Y max was 0.0744. This is a little bit higher than we want. We want it to be 0.04 or lower. And so to change that, you would just mess around with the box here and try to get it to where it's not touching the blade and give as little friction as possible. And then you just keep running it until you get the numbers you want. This is what we're looking at to determine how much force it takes to push through the muscle fibers. So you want this number right here to be 0.04 or lower. We're going to keep working this until we get the right number. It's important to take into account the testing to zero out your scale whenever you create your batch, because every time we run this zeroing, it counts as one of the samples they're testing. We got this one at 0.0308, which is good. It's below our 0.04 number. We'd go ahead and write that down as our Y max 0 number, and we would go ahead and start testing. So whenever we're actually going to core, we're going to go ahead and put the core into the machine. Whenever you put it into the machine, you want to make sure to test the middle of the meat sample. That's because if you get further out to the edges, one way or the other, it's going to be more cooked on the ends, and it's not going to be the true tenderness you want to find in the middle of the product. So you situate it in and fit it right to where the V is going to hit it perfectly in the middle. Once situated, you have it ready to go. You're going to hit T twice again and go ahead and run the machine. Here's our tenderness value. It's 1.2901. That is how many kilograms it takes to push through the muscle fiber and actually break through them. This is the number you write down every time whenever you're recording your results. You're going to keep doing this for every sample you have, all 6 cores. So here's our next number. As you can see, it's not the same. It's 2.2944. It's a little bit different. This is kind of why we take 6 cores. Be sure to pull out the old cores every time. That way it doesn't affect your values. Make sure it's clear and then keep running. You want to make sure to clean out the groove where the meat sample is pushed through in between every sample, just because if you move on from sample to sample, whether it be like we're doing here, a loin to a tenderloin, there's different tendernesses in these cuts, and you want to make sure the excess meat stored in this cavity does not affect anything. So we just use a paper clip, and you can see what falls out down there. We're just trying to clear it out as much as we can. You can also use a distilled water bottle to squirt down in there or something just to clear it out. So you take it and you can just spray it on both sides. It can help get the grease out. It can get extra parts of the muscle fibers out. Whatever's left in there you want out. Basically you want it to be the new test every time you change samples.